Hello everyone, my name is Omar Khan and I'm excited to present my summer research project which explores the impact of avatar appearance and locomotion congruence on user experience and identification in virtual reality. Head-mounted displays can immerse users in 3D virtual environments, which opens up the possibility to explore and interact with virtual worlds. As this technology expands, it's becoming increasingly important to understand the factors which shape user experience in VR. Self-avatars and locomotion methods both play central roles in shaping user experience. There is extensive prior research on the individual effects of both avatars and locomotion methods. However, there's a dearth of research which explores the interaction between these two factors. As such, my summer research project explores the effects that congruence between avatar appearance and locomotion methods have on user experience in VR. Now I'll present a background on self-avatars and locomotion methods in VR. When designing a VR experience, there are various locomotion methods available to consider. Most VR applications make use of locomotion methods which allow users to traverse a large virtual world despite limited physical constraints. This is called large-scale navigation. The most commonly used large-scale navigation methods are teleportation and joystick-based movements. Here are some GIF images which show examples of both of these locomotion systems. Researchers have proposed more natural and intuitive large-scale locomotion methods based on hand tracking, which I will discuss in the next slide. Arm-roll locomotion is a method of large-scale navigation which is based on physics, and it involves the user pushing off virtual surfaces to propel their virtual bodies around the environment. To gain forward momentum, users can move their arms in a circular motion in front of their body. Here's an illustration of me demonstrating this motion. Arm swing locomotion is another method of large-scale navigation for which users swing their arms in a natural walking motion to move around. Here's another illustration of me demonstrating this motion. Arm roll locomotion resembles the movement characteristics of gorillas and other quadrupeds. Therefore, arm roll locomotion is congruent with gorilla avatars. Arm swing locomotion, on the other hand, resembles the movement characteristic of humans. Therefore, arm swing locomotion is congruent with human avatars. Now I'll explain the details of the experiment which I conducted to answer my research question. To answer my research question, I developed a VR game. Then I used the game in a user study for data collection. I developed the MetaQuest 3 head-mounted display using the Unity game engine. The development process involved importing human and gorilla avatars, implementing the arm swing and arm roll locomotion methods, and designing a virtual obstacle course for participants to go through. The virtual environment consists of a start area, an end area, and an obstacle course made of crates and walls. I also placed mirrors around the virtual environment so that users could see their virtual avatars while playing the game. Before recruiting participants, I obtained approval from the Research Ethics Board for the study. Then I recruited 30 participants via social media posts and the snowball sampling method. I ran a within-subject study with 4 experimental conditions illustrated on the image on the right. The congruent avatar locomotion combinations are go roll and hue swing, and the incongruent ones are hue roll and go swing. During the experiment, we collected data from the participants using questionnaires. We grouped the measures into 3 categories: avatar identification, which refers to how much users identify with their avatars; user experience, which encompasses aspects such as enjoyment and satisfaction; and usability, which determines the effectiveness and accessibility of the system. We used standardized questionnaires for each of these measures. Finally, I'll present the results of the experiment. Here are the key findings from the data analysis. Firstly, congruent appearance locomotion enhances avatar identification. Congruent appearance locomotion also improves user experience. Lastly, incongruent appearance locomotion can cause lower usability and a steeper learning curve. Here are several comments which participants provided, which support these key findings. The results of my study have implications for VR design pertaining to fitness applications, physiotherapy applications, and entertainment in VR. Finally, I'd like to acknowledge my supervisor, Dr. Kim, the postdoc, Dr. Nam, and the Alberta Innovates SRS Award. Thanks for listening.